Bismillahirrahmanirrahim. Hai, Assalamualaikum. Okay, today kita nak continue. And the new topic is design of slab. Macam mana kita nak design slab. Okay, so kita tengok. Semester, we must have the determination. Maksudnya apa our learning outcomes. Okay, so at the end of this topic, students should be able to describe. First is type of slab. Okay, then second is explain the detailing of the reinforcement in the slab. Okay, the third is calculate, able to calculate the reinforcement of simply supported one-way or two-way slab. Okay, so saya harapkan by end of this topic, tiga point ni kita dah achieve. Okay, right. So introduction of the slab. Okay, slab tu apa sebenarnya? Slab ni adalah common structural element of the modern building, and biasanya position dia adalah dekat on the ground or supported by beams or columns or walls or other framework. Okay, so slab is a structural member with a cross-sectional height. Okay, with a cross-sectional height which is smaller than the punya width and also length. Okay, so this figure shows the simplest slab, which is having simply supported by two masonry wall. Okay, so this is the slab supported by these two masonry wall. Okay, these two masonry wall, ataupun sometimes they call as a suspended floor. Okay. Okay, macam mana nak design slab ni sebenarnya? Okay. Design slab ni dia, sebab slab ni behavior dia lebih kurang ataupun similar to the beam. Okay, so the design is also similar or somewhat simpler than the beam. Sebab apa simpler daripada beam? Sebab kita consider first kali, the width of the slab is taken as 1 meter in design calculation. Okay, so maksudnya memang macam mana pun untuk design calculation, kita punya width of slab is 1 meter. The second is, shear stress is usually very small and not critical, except for the large concentrated load act on the slab. Okay, tapi bila benda ni, except for kan, tapi usually, kita see point number 4, usually, lab usually carry a uniformly distributed load. Okay? So, and one more thing is, compression reinforcement is rarely used. Okay, maksudnya kat sini slab normally memang kita akan pakai only tensile reinforcement. Okay? So, kita jarang menggunakan compression reinforcement. Okay, ini adalah types of the slab. Okay, so ini adalah contoh flat slab. Kita nampak ni picture. Ini flat slab with the drop panel. Okay, this is a solid slab, rig slab, pre-stress slab, baffle slab. Okay, but dalam topik yang saya nak ajar ni, kita will cover only focus on the solid slab. Okay. Okay, let's see the design consideration. Okay, suspended reinforced concrete slab can be designed either spanning in one direction or two direction. Okay, it depends on the number of the support. Okay, number of support ni sama ada beam atau walls lah. Okay, so this is the example ataupun this figure shows the one-way solid slab. Which is kat sini dia ada beam dan sini ada wall. Okay, so kat sini dia tak ada apa-apa. So this is one-way slab. For two-way slab, tengok sini, dia penuh. Maksudnya dia four-sided. Okay, so this is the two-way solid slab. This is the one-way solid slab. Okay. This one, another example. Okay, so this is one-way spanning slab. This is two-way spanning slab. Maksud dekat sini, okay. Cuba kita tengok, ini dalam point of distribution load. Maksudnya bila kita one way spanning slab, kita akan distribute the load two-sided. Okay, two-sided kepada main beam. Okay. Kalau two-way, kita akan distribute kepada four-sided. Okay, kita lagi contoh lagi akan saya tunjuk. Okay, kita fokus on the one-way slab first. The one-way slab ni is designed on the assumption of the slab consists of the series of rectangular beam 1 meter wide. Okay, 1 meter wide, spanning between supporting beam or wall. Okay, occur only when there are only two support or two-sided only. Maksudnya dia akan terjadi one-way slab bila hanya ada dua support ataupun dua side sahaja. Okay, maksudnya kat sini ada wall, kat sini ada beam. Okay, dia jadi one-way slab. Okay, another one is bila dia support dia support oleh four edges. Maksudnya dia ada empat ini ada beam ataupun wall. Dia ada four-sided. Tapi dia punya ratio is the ratio of the longer span to the shorter span is greater than 2 meter. Okay, bila dia greater than 2 meter, even the four-sided, they will become a one-way. Okay, so the slab is considered spanning in one direction when the main reinforcement is designed in one direction only. Okay, this occur when the slab is supported on the two sides. Okay, yang macam saya cakap tadi, bila mana ada two sides only, so dia akan ada dia punya load distribution akan bahagi kepada dua. Dari sini kepada side ini dan load ini dia akan dibagi kepada beam ataupun wall kat sini. So this is the type of the reinforcement in one-way slab. Okay. Okay, if the slab is supported on the four slide, four dikelilingi oleh floor ni dikelilingi oleh ada four-sided. Dia punya ratio, if the ratio Ly longer span to the shorter span Lx is exceed 2 meter. So this is the figure. Okay. Let's see the detail on the reinforcement. Okay, so the detail on the reinforcement, okay, there akan ada dua. So the main reinforcement is provided to counter the failure in the shorter span. Okay, maksudnya kita tak nak ada failure in the shorter span. Okay. Second, the distribution steel ataupun kita panggil secondary steel, boleh juga distribution steel or secondary steel reinforcement is provided perpendicular to the main reinforcement. Maksudnya bila kita dah determine main reinforcement punya location, so the distribution steel ni adalah perpendicular kepada main reinforcement. Okay, to tie the main bar and helps to distribute the stress due to the concrete shrinkage and thermal expansion. Okay, this distribution or secondary reinforcement will normally be on top of the tension reinforcement. Okay, maksudnya kat sini kita akan nampak main reinforcement kat bawah, dekat atas ni on top is the distribution of distribution reinforcement. Okay, in one way spanning solid slab, many of the design considerations were very similar to the beam. Okay, kita tengok design of the slab for the bending at ultimate limit state. So since the solid slab considered to design for the design purpose a series of 1 meter wide as the beam, tapi menggunakan width dia B sama dengan 1 meter or 1000 mm. Okay, because their purpose kita punya width of slab is 1 meter. Okay, so design of slab for the shear at ultimate limit state. So tadi kita dah cakap dah, shear kalau diminta untuk dibuktikan. It's not practical to provide a shear reinforcement in solid slab supported on the wall or beam. However, kita boleh determine dia punya shear stress. sama ada dia perlu ke tak perlu dia punya shear reinforcement. So this is the procedure. So kita kena cari dia punya shear force at the face of the supporting beam of the wall. So kita akan cari dia punya shear stress by using the equation. I guess you already familiar with this equation. Okay. So now we need to find the VRCD from table 8.1. So table 8.1. Okay, because this is focus for the slab. Okay, then we need to multiply the VRD with the modification factor from the table 8.2. Okay, so if the VED, kita punya VED, the shear stress is not greater than the modified VRDC, then the slab is safe without shear reinforcement. Okay, so kita punya forces VED, itu kita kena cari dia punya shear stress. Lepas kita cari dia punya shear stress, kita cari dia punya VRDC. Okay, VRDC ni saya rasa pun tak ada masalah sebab you guys dah familiar macam mana nak cari dia punya reinforcement ratio. Lepas tu dia punya effective depth. Kita boleh kira dekat mana dia punya VRDC. Okay. Lepas tu, macam mana nak times. Okay, step number 4 multiplies VRDC with the modification 8.2. So this is the output. So kita kena carilah based on the strength of the concrete. Let's say strength of the concrete is 30. So modification factor is 1.06. The times with the VRDC. Okay, so bila modification factor dah times with the VRDC and kita tengok dia lebih besar daripada VED, so the slab is safe. Okay, if this check shows that the slab require the shear reinforcement, maksudnya bila mana VED kita lebih besar daripada modified VRDC, then it is the best to increase the slab thickness and repeat the calculation. Because shear punya shear ni jarang kita ada. Okay. Shear reinforcement is not practical. So kita increasekan dia punya thickness of the slab. Dan kita buat kira-kira balik semula. Alright. So then kita design of the slab for the deflection. Okay. So sama juga deflection is controlled by restricting the span to the effective ratio using the same method as the beam. So maksudnya in the previous topic kita dah learn on the deflection of the beam. So sama juga untuk slab. Okay. And the last is design of slab for cracking at the severity limit state. So yang ni kita akan refer the rules for the minimum bars and the maximum bar spacing in the durability section, which is in the chapter 3. Okay. To control the cracking and also allow the concentrated load on slab to be distributed on the main reinforcement. Bars equal to the least minimum area should be provided in both direction in the slab. Okay, so we have design slab for cracking, design slab for deflection, so design slab for shear, okay, design slab for bending, and the reinforcement detail. So this will focus on the one-way slab sahaja only. So I guess I will continue for the two-way slab in the next video. Okay, I hope you guys understand and can follow my my notes, my video. Alright, okay, thank you. Wassalamualaikum.